Friday, we discussed on how to prove two triangles congruent. We had to do a lot of work. We had to prove 3 pairs of sides congruent and 3 pairs of angles, and that was the last time we're going to do that. All right. When we prove triangles congruent now, definition of polygons will never come up again. We don't need all those facts. We need actually a lot less than that to prove triangles congruent. Over the next 3 or 4 days, I'm going to show you 5 different ways to prove triangles congruent. That'll have a lot less information than all 6 pairs congruent. First 2 today. I'm not going to throw all 5 at you once. First 2 today. The first way to prove triangles congruent. SSS, which is an abbreviation for side, side, side. What that is telling you guys is the following. Hey, you don't need all 6 pairs of angles and sides. All you need are the sides, and that's good enough. So if you can show me all 3 pairs of corresponding sides are congruent, you're done. Don't even touch the angles. You don't need them anymore. You don't need the angles involved. If you can find all 3 pairs of sides congruent, the triangles are congruent. All good? And then, yes, this is what we are going to end up writing in our proof at the end is SSS. All right. Now, sometimes there may not be all 3 pairs of sides. It's not going to be possible. So we go on to our second method today, which is SAS. It is not pronounced SAS. All right. There's a pet peeve, a math pet peeve of mine. It is not pronounced SAS. It stands for side, angle, side. Okay, we need a little discussion here, though, because it does not mean 2 sides and an angle. Everybody see where that A is placed in side, angle, side. Where is it placed? Right in between the sides. That's where the angle has to be on the triangle, though. All right? Take a look at my diagram that I've given you guys. Do you see how in both triangles, the angle is in between the 2 congruent sides? Does everybody see that? Okay? If you want to use side, angle, side, the angle must be in between the 2 sides for you to use it. If it's not, the triangles are not congruent. I hate to break it to you, but there is no SSA and the other version with it flipped. Okay? Some of you picking up on that. Right? It's not possible. Okay? The angle has to be in the middle. If it's not, stop. The triangles are not congruent. Don't try to force it. This is the only way I'm going to show you with 2 sides and an angle is side, angle, side. Again, what do we have to remember about the angle? It's in between the 2 sides. Okay, it's in between the 2 sides. If it's not, triangles aren't congruent. All right, that's the only 2 I'm going to give you today. There's 3 more. I'll give you 2 more tomorrow, but these are the only 2 we're working with today. So what I did is I put up some triangles up here. I marked my diagram a little bit, and now we're going to discuss as a class, is this enough information to say the triangles are congruent? And remember, you only have 2 methods, side, 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 and side, angle, side. So look at diagram 1 for me. I marked 2 sides congruent and a pair of angles congruent. Is that enough to say the triangles are congruent? I'm getting some no's and some yeses, which I expected. Because some of you are saying, well, you said side, angle, side, and I'm only given side, angle. But sometimes there's some things you can mark on your own that I don't need to mark for you. Anybody notice a side that they both share? BD, that's a reflexive side, right? So I can count that in the sides. And just so you know, this is how I roll. Anytime there's a reflexive side, you don't have to do this, but instead of a hash mark, I put an X. That represents a reflexive side for me. So is this side, angle, side, or no? Well, let's take a look. Look at one of the triangles. Let's look at ABD. Is that angle in between the 2 sides? And what about in the other triangle? Is it between them? We got it. So these two are congruent by side, angle, side. What were the directions though? The direction said write A. If they are congruent, write a congruent statement. We talked on Friday, order matters. Order matters. Let's go the easy way here first. 14, name that first triangle any way you want. ABD. Congruent to, let's see, if we go ABD, make sure everything matches up. We're going to have to go what on the other triangle? CBD, yep. And then it also said what? Name the reason why, right? And identify the postulate, yep. So by, what was the reason? Not that they were congruent. Side, angle, side. Two? What do we think on 2? Remember, it's either side, 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 or side, angle, side. You guys don't have much to pick from today. It's one of the two. And if there's a no, it's not possible then. Here we go, 27. What do we got going here? Yeah, because I don't know an angle. I don't know angle F congruent to angle J, and I don't know EG congruent to HK. All right, and don't give me this business. Oh, because 2 sides are congruent, the third side must be. There's no third sides theorem. Okay, it's third angles theorem. Everyone good? So this one, we are correct, not possible. Okay, how many people am I going to get on this next one? 20? To do what? How many sides do you have? 3 sides are marked? Are we looking at the same thing here? And how many angles? So the only option possibly could be side, angle, side. But what's the problem? If you're going to use side, angle, side, what did we just... What? What about it? Is it? Our discussion's over. Angle's not in the middle. Everyone agree? Don't try to like manipulate it or anything. Whatever's in front of you, that's all you get. So this is not possible. Here, the only 2 things you are allowed to mark on your own, reflexive sides or angles, and vertical angles. That's it. All right, you can't manipulate anything else. All right, what about 4? 12, yes or no for 4? Yep, darn right. Here we go. Name one of the triangles. 5, name one of the triangles. SUT. So if I go SUT, congruent to, let's make sure we're in the correct order coming up. If we go SUT, how do you name the other triangle? 25? VWX. Let's see, match up. SU, UT. Yeah, looks good. We never mentioned why they were. 3, why are they? Side, side, side. All right, let's look at 5. I give you a little right angle in there. Did I provide enough information? 28, did I provide enough info? No. Because ready, you got the right angles. You guys could mark what on your own as well? What else could you mark on your own? The reflexive side, but still, is that enough? I got side angle, nothing. Side angle, nothing. And then finally with 6, possible with 6 to prove them congruent. Here you go, 14, possible. It is possible. Name a triangle for me. 30, name a triangle for me. EDC. Congruent to, let's see, if we go EDC, what's the proper way of naming the next triangle? 20? HGF looks good to me. By what method? 27. Side angle side, yep. Boom. You and your group right now, 789. 789 right now in your group. See what you guys have, 789. Bless you. All right, let's hear from you guys here. On diagram number 7, number 12, yes or no? Yes, it is. I like it. Quick question for you, though, 7. I have 2 sides and 2 angles. Usually that's not enough. What did you mark on your own? Reflexive side MK. So, yes. Triangle. Go ahead, name your triangles. KMJ, congruent to, what do you got over here? MKL. How we look there? KM, MJ, looks good to me. By what method? Side angle side, nice job. Don't forget, you can mark a reflexive or vertical angles on your own. How about 8? 26, good or not for 8? Good, yep. Name the triangles, triangle. By what method? Yep. Where was your third side? Because I only have 2 pair marked. There you go. And finally, what about 9? We're good to go with 9 or no? 30, good to go? Maybe you can put in the vertical angles, but what's the problem with the vertical angles? Not in between the 2 sides. Not in between, so it wouldn't be side angle side. Everyone all right with these 2? Okay, a couple quick questions here. Draw yourself a triangle, ABC. Just to make sure we have this concept of in between good. Or we have it down pat. ABC. Doesn't matter the order, remember, you label the vertices. All right, let's go down the list here with me. 27, you're up first. What's the angle between BC and AC? Angle C. What sides include angle B? So angle B is in between what two sides up here? Here you go, 11. ABN. Yep. What angles in between? What angles include line segment AB? 19. What angle? Where is AB in between? Angle B and angle A. Perfect. And finishing this off, what side's in between A and C? 18. Done. Are we okay on winning angles in between? Any issues with that? All right, and then of course we can do proofs with these, but unfortunately, guys, the proofs aren't going to get much tougher than these, because how many methods do you have right now? 2. That's all that's all you can use right now. When we get up to 5, yeah, then you have to be like, shoot, which one do I need to use here? But when you have 2, the proofs aren't too bad. Like this one, as you'll see. I'll take care of this. Actually, I should have asked somebody that reason. See what some of you would have to say. Why is AC and CA congruent to each other? 24. It's reflexive property. And then give me a method why the triangles now are congruent. 8. Yep, and that's exactly, guys, what we can write in the reasons column, SAS. If you want to write out side angle side, feel free, but just need the abbreviation. And like I said, they don't come too much tougher. Diagrams marked for you already. I got 2 pairs of congruent sides. Not enough to prove the triangle's congruent, though. I need something else. Need something else. And also, just a quick comment. If you're doing a statements reasons proof, not possible is never an option. Okay, it's always possible to prove the triangle's congruent when you're doing a statements reasons proof. All right, so please don't write me a little note saying it's a trick proof and it's not possible. All right, that's pretty embarrassing. 19, what else do I need here? It is. Somebody know why there for me. How about 6? Why? What about them? I need more than that, though. Vertical angles are congruent. Yep. Definition of vertical will never work. Definition of vertical angles never work. Is it enough to say the triangles are congruent? Yep. 2, why? Correct. And what's great about the proofs is I love them anyway. I don't have to think about the order. Writing the congruent statement, it's already given to me. All right. So don't stress out on the proofs tonight. Enjoy them because they're going to get tougher. Last thing we got to take care of is what happens if I'm on the graph. Some of you may or may not know what's coming up, but go ahead and graph both triangles. All right, so we got them graphed. It says determine if they are congruent or not. Well, guys, hey, we've only gone over 2 ways, right, to prove them congruent? We've only gone over side, 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 and side, angle, side. And I hate to break it to you, but when we're on a graph, how are you going to prove angles congruent? Unless they're a right angle. I don't know either. All right, so that pretty much eliminates side, angle, side because there's no way I'm going to get an angle there. But how could I do side, side, side? Distance formula. Hold on. John Carlino. I do. Absolutely. Yep, bye-bye. So I could do distance formula here. All right, so we could start with one of the triangles. Let's start with PQN. Find the distance of PQ. Find the distance of QN. Find the distance of PN. And then I would go and do the same thing, and this is what I'm going to ask you to do tonight. Triangle JKL. JL distance, KL distance, JL distance, and hopefully what will happen here at the end when I'm done. Hopefully all 3 pairs will match each other. All right, so I will put the answers up here while you continue to work. Do we need a reminder of the distance formula? Big square root, x2 minus x1 squared plus y2 minus y1 squared. Hopefully you're getting the square root of 18 and 17 out. Break down 18 for me, though. Keep going right up to the